So yes, welcome everyone. Thank you, Jonny, for coming. Just as a very brief introduction, today we've got Jonny Rae speaking, who's a professor at Northumbria University, an expert on all types of plasma physics across all different bodies in our solar system as well, but mostly focusing on the Earth. We've invited Jonny today to talk specifically about their role as a space scientist advisory committee member for European Space Agency. So that they're going to talk a bit about that, and we'll have some discussion too. Over to you, Jonny.
Cool. Thanks, Jasmine. And thanks, I suppose, for the invite. I largely regret mostly the title, not actually saying yes to it. Can you see a laser pointer? I'm not very good with Zoom.
Yes.
Cool. Thanks. So yeah, thanks for the invite, and hopefully this should be some good information and a bit of a discussion. And I'm happy to be interrupted as well if people want to ask questions along the way. So I had a sort of a lofty title, and then I thought I'd make it more lofty. So it was originally international cooperation in the European Heliophysics community. I thought I'd put in a little bit of national as well, given the fact that this is a missed seminar, and there's a couple of observations I'd like to make in terms of that as well. And both of them, the national and the international, really have the same message. These large endeavours that we try and put together require us to talk and to collaborate and to get in the same room and talk the same language, and that's probably the take-home message for the rest of the talk as well. It probably doesn't come as much of a surprise to people. So there are risks and rewards of us being a large and diverse, an excellent research environment that MIST is. The MIST is. We have a number of ways to try and figure out how to get funding, and that's a really good thing. If you're an astronomer, I think probably you're more limited to STFC, for example, and the UK Space Agency, perhaps. But if you're interested in space, in heliophysics in general, we have a few more avenues that we can pursue, and that really helps, I think, in terms of the small projects and the little niche discussions that we have. But it may also come with a few bits of risk as well. So I'm listing here STFC, NERCy, NERCy, the Royal Society, Royal Astronomical Society, UK Space Agency, and the Leverhulme Trust. I've probably missed a few more. But the question I suppose I've got is if there is some reward of being cross-disciplinary, interdisciplinary. How do we really know where to go for our funding in terms of basic science or applied science, new techniques, artificial intelligence, and other techniques that we are starting to get into? I think infrastructure and hardware are two hugely important aspects if we're going to exploit science from instruments or on the ground or in space. Where do we get the money from for that infrastructure and that hardware? And is it really a coherent program? Where do we look for PhD students, early career researchers, might be interested in travel grants and fellowships? And so the fellowships, I think, are probably quite clear. But how do you try and become familiar with all of these opportunities without spending your life looking at just those opportunities? The Leverhulme Trust is a good example. They would like to be a funder of choice, and it's easy to say, yes, I'd like to apply to the Leverhulme Trust because it can't be NERCy and it can't be STFC or it can't be the Space Agency. But why would you actually? Why do you want to choose a particular funder? Those are kind of more difficult questions to ask and answer, and maybe talking about it with colleagues across the country may help with that. A wonderful example of cross collaboration, discussion, the culmination of years and years and years of work, I think, is the swimmer program, and I'm just listing here. Well, let me talk about it first. Swimmer being space weather instrumentation, measurement, modelling, and risk. It's a £20 million investment in research to operations to provide the UK Met Office, the UKMO, with tools and resources to help predict and monitor the space environment around Earth. And effectively, that is a super critical thing that we can have that goes alongside the NOAA forecasting capabilities in the Space Weather Prediction Centre, but it's our own, and it's an independent service, and it's a phenomenal program that was put together and led by Professor Ian McCree, who I'll come on to in a second. We know that space weather risks are part of the National Risk Register, and that risk is owned by the Met Office. And so trying to help them provide that risk mitigation for critical national infrastructure and industry stakeholders is a super critical part of our applications, part of our basic research. It lasted for at least 5 years, and I think a number of people have had extensions for this into 2024, but after that, we're basically done. And that program led to a massive increase of talented early career researchers that have gone on to, I want to say bigger and better things, but they've gone on to excellent opportunities following on from swimmer. And one of the questions I think I've got is what happens next, and I'm not alone in asking that question. This is on the right hand side here is a web page that was transitioning from swimmer to something that happens next, and this was a program put together by Mario Bizzi, amongst others, that was held last year, and I hope that there will be another one next year. Getting together, talking with everyone, and trying to figure out what's next. And a few of those down in the bottom left-hand corner, maybe we're now part of Horizon Europe again. Maybe that's a good opportunity. But there are also some large, I should have put this in the opposite way around, STFC large grants are a new thing, up to £3 million. NERCy large grants are an old thing, up to £3 million. And if you're thinking bigger than that, maybe this is where we go from smaller to larger, and then to very large. STFC Visions and NERC Big Ideas. They're two big calls where you can put in ideas that you might think would be cross-country, cross-institute, large endeavours to follow on from swimmer or something similar. And I just wanted to highlight, we were talking about this before the recording started, but a number of colleagues in the field won a number of prestigious prizes on Friday from the Royal Astronomical Society. I just want to talk about one of them, and that's for Professor Ian McCree, who has absolutely spearheaded the swimmer program, as well as ISCAT, as well as ISCAT 3D. And so huge congratulations to him for the RAS Service Award from Friday. So there are some rewards, there are some risks. So there is a problem with interdisciplinarity. Who owns that interdisciplinarity? Who will fund that research across different aspects? So swimmer was a good example. It's funded equally by NERC and STFC, being two part funding councils of UKRI. UKRI was part of the Department of Business, Energy and Industrial Strategy. Recently, that was split into 3 different departments, and I'm listing those. They have terrible acronyms: Department of Energy, Security and Net Zero, Science, Innovation and Technology, and Business and Trade. The UKRI, our funding councils, UK Space Agency, and if I understand correctly, and I know that there's people on call, they're all in a different department than the risk. So that's an interesting question on what happens next. If you are a risk holder and you want to mitigate from risk and you don't actually have the tools in your own department. So who funds that? And how can it cross governmental departments? There are elements of impact expert groups. So this is a link to Space Environment Impact Expert Group, chaired by Richard Horn, but the members of that expert group are also listed in the link that I'm providing, who may serve as a bridge to the governmental departments that I'm talking about. And perhaps we want to engage with those a little further. And I also want to point to a report led by the Rae Group, a Swimmer S6 report, Space Weather Impacts on UK Critical National Infrastructure, coming out in March. And if you're interested, and I hope you are, a workshop on the findings and recommendations that we've put together, please contact Matt Alcock for details, and I'm providing his email address here, and I know he's online to answer any questions. If I move on from that into STFC versus UK Space Agency, I think both STFC and UK Space Agency will tell you that their relationship is clear, but in reality it's complicated. So I'm going to talk a little bit about technology readiness levels, because I can't say it properly, I'm going to call it TRL. STFC funds the basic concepts of instrument development, whereas UK Space Agency funds the full development. And so if I go to another schematic here, TRL1 is a basic principle, TRL4 is a functional verification of an instrument. If it's 5 and above, making and breadboarding an instrument up to flight, then UK Space Agency will fund that. There is a statement that there is to ensure a smooth pipeline through dual key funding, which if I flick back slightly, gives you an example here of what happens. The decision making should be between the two agencies and councils, except from my personal perspective, that doesn't work particularly well. There's no real separate call in STFC for technology. And that means that the technology, when you're trying to develop that technology, there have to be graded through the science program. And so the technology is graded for its science. And if that science is not graded to be world leading, then that will create a stagnation in technology. And that poses a real problem, particularly when we start working with European Space Agency and other funding agencies to try and look for state-of-the-art instrumentation and moving forward ideas into reality through missions. In terms of funding councils, I think there's a good example here for STFC and NERC. It's also clear but complicated. STFC would fund Blue Sky's research into space, whereas NERC is in applied science and its impact on near Earth. But the question I think that you could ask 38 people on this call and more online, where is that line between STFC and NERC? And I think you probably get a number of answers, none of which, some of which would be similar and some of which would be less similar. There are discussions about the NERCosphere, whereas 1,000 kilometers and below, and maybe that's where the line is. Maybe it's on the impact on near Earth and how much of an impact on near Earth. But certainly that's a grey, fuzzy line. More importantly, I think, equally importantly, what do we do with the facilities, hardware, infrastructure? We have radars, we have ground-based instrumentation. If my funding council doesn't really know that it funds it, and it thinks that a different funding council funds it, I have a real problem. NERC is a good example that there are times where NERC is not quite sure who is funding what facility. And so I've just written here strong advocates on panels. I think that's a super critical part of what we do and how we nominate ourselves or self-nominate or nominate our colleagues to try and have strong advocates on panels. This is very, very important. And that leads me, I think, to what I was really asked to talk about, the super easy thing, to talk about the European Space Agency and international collaboration and cooperation. So how does ESA work? Well, I think Elmo says it best, but I'm not sure. But I've sat on a number of panels for a number of years, been very fortunate to be invited to do that. So why don't we just talk about it before I get hypnotized by those lovely eyes of Elmo. So there are a number of different documentation. The European Space Agency does love documentation. I've taken this out of one of them. It's an ESA document from last year. There are 99 of them, and I suspect there are a lot more of them. These are a structure of advisory groups that scientists such as ourselves can get involved with to advise the ESA Director General, the person in charge, on the science that they would like to do. So there are 5 senior committees in different directorates, and I will go through the ESA directorates as well shortly. The Space Science Advisory Committee, that's something that I sit on. The Advisory Committee for Earth Observation, and that's in the Earth Observation Directorate. GNSS Advisory Committee, Human Spaceflight Committee, Space Situational Awareness Committee. And advising those groups are working groups. And there is an astronomy working group, there's a life sciences working group, there's a physical sciences working group, and a solar system exploration working group. And I know that Katrina Jackman, who popped up on the chat earlier, she's part of that one, as is Geraint Jones. So how does this work? Well, this is the simplest thing that I could put together. I'm just going to check the chat just in case there's questions.
There's no questions. I'm keeping an eye on it, so
okay.
I'll interrupt you if I need to.
Thank you. I will be used to that, Jasmine. Thank you. Where was I? I was talking about this very complicated. So the ESA Director General sits somewhere up here, and there are at least 6 directorates that involve space weather science in some way in the European Space Agency. And I think that's, again, something back to what I was talking about in terms of national and international collaboration. This is a risk, but also, sorry, this is a reward, but also a risk. So we typically think about our science to be part of the Directorate of Science. This is where missions such as Cluster and SMILE and JUICE come from. Bepi Colombo. But our science also sits in other missions, in other directorates, sorry. Earth Observation is the SWARM mission, for example. Human and robotic exploration would be where lunar gateway science might exist, and certain Mars endeavours as well. If we're thinking about space situational awareness and missions such as Vigil, that would sit primarily within the Ops directorate, sorry. And navigation is interested in GNSS, such as Copernicus and Galileo. I've missed out tech. This is a technology directorate, and the technology directorate underpins the work that goes on in the other 5 directorates. This is obviously related to the technology that the other directorates require. So it's a cross directorate, if that makes any sense whatsoever. And so if I go back to our reports of the SSAC, the Space Science Advisory Committee, we sit under the Directorate of Science, and as Katrina has mentioned in the chat, The Solar System and Exploration Working Group is in this area here that comes and informs the decisions made at this point. The Physical Sciences and Working Group, which I think Ruth Bamford has certainly sat on, if isn't sitting on right now, and Claire Watt reports to the Human Exploration, and actually does also feed into this advisory committee as well. But all those directorates can request advice from any of the working groups, and I'll try and discuss what that really means. The two easiest discussions that I can talk about, the most visible to our field, are the Directorate of Science and Directorate of Earth Observation. And here, what I'm trying to represent here is where we can get involved and where we can less get involved, I suppose. So in red, we have community scientists such as myself. And in blue, we have either ESA employees or National Space Agency delegates in some way, or indeed industry in Earth observation. So science, the Science Programme Committee is made up exclusively of ESA employees and Space Agency delegates. And that's the same as true in Earth observation. I've got this sort of side idea here, which is kind of goes alongside the program board in Earth observation. But what I'm trying to emphasize, and what I'm hopefully going to emphasize later, is that all of these 4 committees here have community scientists and almost exclusively community scientists within them, and you can get involved, and it's more open than it ever was now. So multiple people represent our community on the science committees. I've said that the Science Programme Board, this senior that makes all the decisions, doesn't have scientists on it, except when it does. So some of these people that you'll recognize here, Jan Socek, Emilia Kilpur, Janos Lichtenberger, Arpad Kiss, they work alongside their national delegates, and they are invited and indeed involved in Science Programme Board. There are people at the Science Advisory Committee, Space Sciences Advisory Committee, Louise Hara, myself, Olivier Grasset, who's the current chair, Solar System Exploration Working Group, Katrina Jackman, Geraint Jones, Manuela Tema, Francesco Valentina, Viviane Girard. And in Earth observation, there is one person in our field, and that's Kathy Wheeler. But there are people who you can ask and try and ask to see what's involved in this. And part of what I think I should be doing is giving more talks like this to try and make this more open. There are multiple senior science committees that have dealt with mission review processes for M7 and F2, and we can talk about the process. We can't talk about the results, obviously. That's an internal subject to I've forgotten the words, confidentiality agreement. What stays in the committee stays in the committee, but the process itself, we're very happy to talk about. So the senior science committees and mission reviews, Peter Gallagher, Katrina, myself, and Yuri Spritz have all served on that and served recently. And what we find, at least from a personal perspective, is that when we have community coherence and exciting missions, obviously, that's really crucial to help committee members support the great science that you're proposing. And I think that the M7 call, of which we've got 2 really cool heliophysics missions out of in the down selection, I think that's a great demonstration of that. So please talk to someone about the process or anything. We're all happy to help. One thing that I was talking about a little bit earlier is that I was asked myself in a closed environment whether I would like to be part of this committee. This is no longer the process, which is phenomenal, and things are changing within ESA as part of a big shake-up. So there is a new process proposed, an open call to nominate yourself or others to be part of these committees. I strongly encourage everyone to talk to people who sit on the committees to see what's involved. It is a time commitment, but I bet it's not as long as you think it is. But please consider nominating yourself for any of these committees. It really makes a difference, and I think that that's something that I cannot stress enough. And so there is a deadline. I'm glad that I'm giving this talk this week and not next week. The deadline is next week, 22nd of January, and I've just given you a link there to nominate yourself for a science advisory membership. It is quite a simple case. And people are interested in early career researchers as well as more senior. And I hate to call myself more senior, but I am. Let's face facts. A couple of information slides. If you're interested in this, the Directorate of Science advisory structure, I'm just showing it here, or who your delegate is. And that becomes super important if you're interested in funding a mission or trying to get something through the complicated web that is ESA. A couple of slides on Voyage 2050, and then I'll try and get into M7. We selected, or it was selected, 3 L-class missions for Voyage 2050, and one of those is a heliophysics mission, Moons of the Giant Planets, which is great. One of the things that we would like to talk about in terms of the European Heliophysics community, can we find interesting science to do with other disciplines missions? And we would like to talk about that regularly at different times. So it would be really good to try and plan and try and get excited about those missions that are selected. This leads me a little bit. I've already talked a little bit about our branches of physics, heliophysics lie in 6 different directorates, but ESA recognized this as a challenge, and they set this up and as a result have set up something called the Heliophysics Working Group, chaired by Matt Taylor, and it involves elements and representatives from all of the directorates here. And one of the reasons that becomes important is because not all directorates know what kind of heliophysics they are actually doing. So that becomes very, very important so that we can tell ESA and tell all of the different directorates where we would like to make progress, where we have certain elements of funding, and where we would try and go for other elements of funding to get a coherent program across ESA. It's still considered that the Directorate of Science is still the place where big fundamental science can be done, but it's not really the other one. I guess that's a question that I've already answered. It's not really the only one. There are elements and missions in other directorates, and working and having those directorates work together would be a huge benefit to our community. So it is both a problem and an opportunity. And I'll talk a little bit about SWOT analysis, but not really that much. I'll just direct you to some slides about that. My most important question, I think, is which directorate does take responsibility for our science? That is a significant risk, I think. The reward is that lots of them do it. The risk is that no one really currently takes charge. And what does that mean for missions of opportunity? So there are many missions of opportunity that I know that a number of you will be working on listening to this: Solar Sea, MUSE, Helioswarm, Geospace Dynamics Constellation and Dynamic missions, and specific magnetospheric missions, ISTP Next, and MAGCON. Where do those sit, and how do we start to think about funding missions of opportunity across ESA and the UK Space Agency? The really cool thing that came out last year was that the M7, the 7th M-class mission, was a great success for heliophysics. there was a new phase sort of listed, because there were 5 exceptional candidates, of which 3 of them here, Calico, Calico, Matisse, and Plasma Observatory, were heliophysics missions that went through mission design for the first time. Instead of a down selection to 3, there was a down selection to 5, and they all got a design where they started to practically look at what that mission looked like, and whether that was feasible within the cost constraints and the technology constraints. The down selection was exceptional for us. 2 of them made it through, Matisse and Plasma Observatory, and I congratulate them both for that. And they will proceed through phase A as usual to down select to a single mission in due course. And so one of the things that I'd like to highlight are the 2 people and the 2 missions that we would like to sort of get behind and work towards creating the best missions in this process. And I hope Beatrice doesn't mind. I stole a photo of her, and I hope Federica doesn't mind. I stole a photo of her, of the 2 PIs of the two missions that were selected, Matisse and Plasma Observatory. And I'll give their email addresses. Please get in touch and try and figure out how to get involved. I certainly will be doing the same. I want to slightly talk about the process of selection of those missions, and it may also have a little bit of a, it may also resonate with communities and selections within NERCy, within STFC. Astrophysics is considered huge. It's a huge mission. It's a huge community, and heliophysics is a bit smaller. So when you start to try and figure out what the contribution and the composition of a panel is, I think that's reflected in the composition of the panel. So when you get a request as a panel member, you may only be one of 2 or 3 experts within heliophysics. So it's an important job to advocate and to critically assess the missions that you get. There are additional members needed for specific reviews when there are conflicts. The proposals themselves go through a multi-stage peer review and I've mentioned here with a panel composition that reflects the number and discipline of submissions. So trying to figure out how many people you need for astrophysics versus heliophysics, for example. And those proposals also receive a technical and financial review from a future studies, which is a different department again. So I've highlighted a couple of times that there is the cross-community backing. The magnetospheric community back cluster is the mission that they wanted to fly in the next 20 years and was successful. We have 2 potential missions in Helio, Plasma Observatory and Matisse. Let's try and do the same thing again. So try and find some science and some interest and some enthusiasm. Think outside the box. This would be a fun time to think about that. So I think that a couple of things that I've recently thought about, mission extensions, but short, medium, long-term views, my personal perspective. Really, again, I'm just going to say the same thing again and again, the center around a cohesive community support and suggestions. And actually in the involvement of early career researchers, which we may not typically think about doing for missions, but those are the people who are going to be studying whatever we're going to be proposing. So we need to involve them early and often, and they have phenomenal ideas. We would like community support for mission extensions. We really absolutely 100% need to engage with our space agency delegates and senior committees, missions of opportunity where possible. Our medium term is try and figure out support for future missions, as I've talked about, and prepare community-driven inputs for new missions. And the M8 is the 8th M class, F3 is the 3rd F class. So let's try and think about this on a long-term view. I'll probably skip a little bit of this because I think that I am waffling on too much. But it's the same things again. Keep talking as a community early and often. There are such things as the European Heliophysics Community Newsletter and a meeting that we're hoping to put together for November next year. Involve everyone, our early career researchers, our world-leading ground-based and modelling communities. These are fundamentally important communities that we need to engage with. I would say that my personal opinion is we've been explicitly commended on our recent growth and maturity of science and community coherence. That's, I think, ESA telling us that we're doing a good job in terms of gathering behind exceptional mission and science objectives. And two of those for sure are Plasma Observatory and embassies. So I guess my strategy, we need to talk both to ESA and the members of committees to give them ammunition to put your ideas forward. We also need to talk nationally in terms of our SPC delegates. Those are the UK Space Agency, for example, for ourselves, but other space agencies across Europe, and encourage our early career researchers to be heavily involved. These are the people that are going to be doing all of the interesting science when I've retired, and that's a frightening aspect, but it's a fundamental reality. So how do we interface with ESA? Don't know is the answer, but there's no real one answer, and I think that's probably clear. We know that, but I hope I've provided a little bit more visibility on how we might interface with ESA. And part of that is through our national delegates, and we need to know who these are. Caroline Harper and Ryan King are ours, and we need to support and help them, give them ammunition to arm them for their work at senior committees. We need to talk we need to propose and nominate ourselves through committee work. It really isn't as much work as you think it is, and across all the directorates. And that is a key that the ESA Heliophysics Working Group is working on, and we're hoping to form a coherent European heliophysics community as a result. So let me switch gears a little bit, maybe for five minutes, on what we did last summer, or last November really. We got together a workshop spearheaded very kindly by Matt Taylor at ESTEC. I think something like 260 people registered, about 180 people participated, which is a great start to this. So the ESA Heliophysics Working Group organised this meeting alongside the community to improve the communication between our community and all of the ESA directorates that I've been talking about. Highlight opportunities, synergies, and actually threats as well, but highlight future coordination efforts. So a science organising committee was created, hopefully comprising a broad range of the community for that initial meeting. And I'm providing the link for those who didn't participate or weren't aware, the link for the workshop below. What we did, we talked exclusively for a week in ESTEC on what ESA does in terms of heliophysics in session 1. Trying to identify and build bridges across the heliosphere in session 2, addressing open questions, trying to understand where we're missing observations or measurements or models, and investigative techniques through, for example, AI. We had a couple of topics here, or 4 subtopics: interdisciplinary science topics, potential mission concepts, trying to understand multi-instrument and general science that we would like to do across the heliosphere, and then data analysis methods and instrumentation. Session 3 was building a network and a community hub. And so we tried to rally around specific ideas and try and flesh those out. And session 4 was kind of a summary, reporting what we did, a summary, talking about strengths, weaknesses, opportunities, and threats. This is a SWOT analysis and what we would like to do moving forward. So what we then did is trying to write a set of observations and a set of recommendations. And we didn't get away scot-free. It wasn't just recommendations from us to ESA, but it's a list of recommendations from us to the general community as well. So we also have some work to do. So there's some information there on what we did and where we got to, and I'll invite those to read those at your leisure. But we iterated these around until we were happy with them, and then released them to the community. And what we'd like to do is have an update on the status of these recommendations at an EGU splitter session. So we'll try and do that to say, this is what we would like to have, we said we would do, this is what we've done, to show that progress has been made. And I think that these are a lot of words. So maybe this is too many words to read, but these are things that we decided that we had as a recommendation to our community from the attendees. Deciding a single term to describe the community is challenging. It's very difficult, and we spent a long time talking about this, but the European Heliophysics community was a good umbrella term if we were well defined, if it was well defined. So we should try and construct an agreed list of keywords describing what we really mean by the community. The meeting attendees observed that this was experimental, but very successful, and brought together a remarkably diverse range of the community. So we thought it was a good idea, and we'd like to do it again. We would like to do a splinter meeting at EGU to figure out if we've done our job by doing some of the recommendations. So that's what we've done. And we should try and use email lists such as the European Heliophysics Community newsletter to try and act as an information conduit. And if you don't know how to subscribe, please let me know. Moving further, we did know that we weren't complete. Not all disciplines or career stages were represented. So we would try and spread word. And one example of this is this presentation, I hope, connecting more people to the EHC. One of the interesting things I thought is perhaps potentially a need for training program or mentoring program for ECRs. If we're going to bring them into mission concepts and mission programs, then we need to help that. So there is a community, and this was extremely active during the conference, and I'm showing, I'm just highlighting here where this is. This is another chat form, but it's better than most, and let me put it that way. And I really enjoyed it once I understood it. Zulip was set up by the ECRs and used extensively. And we talked about the idea of a community roadmap, and perhaps that should be a focus of a dedicated session at a future meeting, such as the one in potentially November. What did we ask ESA to do? We asked them to continue the ESA Heliophysics Working Group. We congratulated them on it, which is great. We made a request that all heliophysics activity should be ingested and inserted into this Heliophysics Working Group, which currently it isn't. We would like to have this meeting again, and with ESA backing, and future meetings should have several dedicated online conveners. So we should try and have a real hybrid meeting in future with more dedicated online conveners. We highlighted to ESA that ground and space-based facilities as well as modelling was a key component of our science. We highlighted to ESA that ESA worked towards improving data accessibility from all of their missions and discoverability, which is a very difficult word to say, but lists of useful data and archive links of all of the missions and facilities relevant to heliophysics. And that the working group provide a comprehensive guide that covers all relevant ESA activities related to heliophysics in future. So just a couple of more slides, and then I'll stop. The notes, the slides from the meeting that the heliophysics working group sent to the ESA directorates are in here and here. We've made progress in building a European community, but how do we keep it going? One of the reasons that I'm talking to you today is to try and promote the EHC, to try and get people interested in talking about all of the opportunities that I'm talking about today. We'd like to meet and discuss where we are with regards to the recommendations at EGU, but at other conferences and other sessions where the rest of heliophysics may reside. I'd like to advertise a European Heliophysics meeting, likely in November, likely at STEC, with a combined ESA Heliophysics working group and an EHC meeting. I think that we are at the point where we should broaden it to outside of Europe, based upon international collaborations such as Helioswarm or geospace dynamics constellations, Solar Sea, icy moons missions. And the last thing I think is get self-nominating. You've got about 6 days, I think, but it's well worth getting that insight into science advisory structures. So I guess I'm supposed to have a summary slide. I don't really know whether I've got it, but this is my last slide. I think we're in great shape. We've got some great ideas nationally and internationally. How do we really do this, I suppose? And I suppose I've just written this. Big ideas, big projects, significant progress on science ideas need collaboration, coordination, community-driven support, and a huge amount of early career researchers heavily involved from the start. This is their future we're talking about. We've got nationally a whole bunch of ways to get large ideas through into funding councils and space agencies. And I'm just listing a few of those here. Internationally, I've spent a little time talking about design and exploitation, community building and newsletters, and engagement with ESA and decision makers. And I hope that there's some information that's useful for you in this presentation that I've just given today. Thanks very much.